Kwali Planeshli, good day. I am here on this day to show you the completion of some research that I have done and concluded, which is what I will call the Nepohualtzit. Ne, which means non-specific. Poal from Powali, which is count, and Sit, which is small. Nepohualtzit. Nepohualtzit, which you can see is big here, but when I give you a copy, it will be small like this. Or in English, we'll call it the calculator. Well, this calculator, which actually you've seen this before, it looks like the Aztec calendar. It is, except it has numbers in place of the symbols that it had before. So, how did I derive this? I derived it from the studies of our ancestors, which used to use their count inside of these. And what we call the tonal powali, but it was also used for counting. Counting because in our count, as extensive as it was, we needed space, and you'll see it in a second here. You have the 20s column, the 400s column, the 8,000th column, the 160,000 column, the 3.2 million column, the 64 million column, the 1.28 billion column, and it just keeps going on. Everything multiplied by 20, each column multiplied by 20. Where you have the decimal system that you use here, we use the base 20 system. Decimal is what you call base 10. So what we would do is we'll get this page, or this material here, plus this material here, and then we would sort it all out, or resort it, to come out with our conclusion here. If it happens to get too large, when you get the whole tonal powali and extend it, it looks like this. And you can see that it takes quite a lot of space. So we'd have enough area to work our numbers with. And divide it up. If it was small, we might only need 1, 2, 3 pages. Start here, plus this, and conclude here. So this is flexible. Now, in this case here, as you see the circular patterns, it's a little bit different. We're starting from the center and working out, and from the outside and working in. For addition and subtraction, we work from the inside going out, and for multiplication and division, we go from the outside coming in. How is that? Very simple. You have to remember, first of all, you have 1, 2, 3, 4, 5, 6, 7 circles. The first circle you're going to see is, this is the 20, this is the 400 circle, 8,000, 160,000, 3.2 million, 64 million, 1.28 billion. So you have 7 circles. And I will now show you how these circles are applied in math, step by step. And we'll transfer over to this next picture here. So here, in front of you, what you have is what appears to be the Aztec calendar, but it has numbers in it. And if you notice, you have 7 different, somewhat circles. In the first circle in here, you have 20. 1, 2, 3, 4, 5. 5 and 1 is 6. 5 and 2 is 7. 8, 9, then 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you have a total of 20 you could fit in here. Once you get to a 20, you complete your 20, you throw that 20 out here to the next circle, as opposed to what you would say columns, as we talked earlier here, columns. So what you have here is different circles. So in this circle you have 20, and then 20 times 20, there's 20 here, is 400. And 400 times 20 is this circle here, 200s each of these. So 20, that was 400 times 20 is 800. There's 8,000 in here. And 8,000 times 20 is 160,000. And this 2K each of these represents 2K. And then 160,000 times 20 is the 200K. That would be these here. And these are a total of 3.2 million. And then again, times 20 would be here. That would be the square ones, all the way around. That's 64 million. And again, times 20 would be this 160 million here, these here. And that would be 1.28 billion. So as you can see how everything is accelerated in multiples of 20s, the same way as the Mayan math was constructed. So when we fill this up, we go to the next level. We could have gone further, but we decided that was high enough. Or I guess I said I did, right? And so this is how you do it. Very simple. Where the Mayans used the dot and the bar and the shell, the dot representing 1, the bar 5, and the shell 20. What we have here is something different. We just have beans and numbers in the circle. It's already constructed. So we call this, in English we would call it the calculator, right? The mini calculation machine, or the Nepohualtzit, which is the small counter. So here we say, and why do we call it small? Because in truth, its actual size is this size here. And you place your beans in the different locations so you can see them representing the different numbers that you'll be covering, whatever they might be. Now this is how you do it though. To do this, you say, let's say for example, in adding, because we could add, subtract, multiply, and divide, you say 21 plus 24, let's say 24. Everything's on the table. You say 20, outside circle first, 20, that's 40. There we go, 40. 5. I'll do that again. 21 plus 24. That's 45. There it is. There's your answer. Simple. Let's say you have 365. There's 200, and then you get right here 360. There's 300. 1, 2, 3, 4, 5. 300. And 3 more. That's 60. 5. So 17. let's add 17 to it. There's a 10, a 5, and a 2. So what do you have? You have 365, 15, 22. That's 322. It's all there. 200, 300, 60, 70. What did I say? That's 60. Oh, I made a mistake, I think. Okay. 70, 82. 382. So, there's your answer. Okay, let's say, for example, let's subtract. Adding was easy. Let's subtract. We have 20. 20 minus 3. Wait a minute, we don't have to add anything. We're going to take it away. So we have to bring that 20 into this circle because you can't take a 3 out of that circle. You go into this circle and we bring that 20 in here. So we have, example, 15 and 5 more. That's 20. Take the 3 away. See? 10, 15, 20. Take the 3 away. There's your answer. 10, 15, and 2. That's 17. Say, for example, you have 60 minus 37. That's a good number. It's odd enough. Okay, minus 37. We don't have to add a 37. We're taking it away. So, first we're going to take the 20, and we know that what's left is 17. So we put the 7, no, we put the other 20 in here, correction. To make 37, there's still 17 we want to take away. So we put the other 20 inside of here. And we take the 17 away. That's 10, 15. Oh, no, I was wrong. Yeah, 30. Sorry, my mistake. We take away, that was 60. We took 120 away, right? We took 120. And we have the other 20 in here. And we're taking away 10 more. That's 30, 35, 36, 37. There's your answer, 23. Okay, let's try something else then. Let's say 100. Here we have 100. 20, 40, 60, 80, 100. Minus 50. Okay, we take the 40 away. We still have to take one more 10. So we bring the 20 in here. And we say, there's my 20. That's 10. And 5. And 5. 20. Take the 10 away. We have 20. 5, 10. We have 50. So, there's subtraction. Not so difficult. If it's a bigger number, 235 minus, okay, let's make it sound a bit more difficult. Instead of just taking 35, let's take something bigger. 235 minus 117. Okay, let's say there's that 200. So I'm going to put the 200 in here. Okay, I'm going to bring this 20 over here. 235. It's still 235. See, it's just the 20's in a different place. But I'm doing that so I can put the this 200 inside of here. So we still have 200. If you notice, because remember these are 400. There we go. And there's another one. That's 1, 2, 3, 4, 5. That's 100. And 1, 2, 3, 4, 5. That's 200. So we say, what were we taking away? 100 and 17. Okay? So we take away 100. 1, 2, 3, 4, 5. 117. We can't get 17 out of 15. So we got to bring the 20 inside. Let's bring the 20 inside. And I'm going to put the 20 in. Okay, let's see. Okay, we'll make 2 10s and 2 5s and 1 more 5. Now we have 2 of each of these. So we could actually have more. So take 17 away from that. I'll take 1 10, 1 5, that's 15, 16, 17. What do I have left? I have 100, 10, 15, 18. 118. There you are. Didn't have to do any paper, and it all worked out. Now, let's try multiplication. Okay. Let's try 20. Very simple. 20 times 5. 1, 2, 3, 4, 5. There you have it. 100. Not so bad, is it? Okay, let's try something different. Let's try division. Division's interesting. People get mixed up with division because it has leftovers sometimes. No problem. Let's start with a simple one first. We'll start with back to the 100s. 100. 1, 2, 3, 4, 5. Divided by 20. Okay, how many 20s? The algorithm says how many 20s are there in 100? There's 1 20, 2 20s, 3 20s, 4 20s, 5 20s, and none left over. There's 5 20s in 100. Alright, so we would say divide 20 into 100. Now, okay, that was easy enough. Let's try something more complicated. Let's try 30. I don't know why I got this 37 in my head, because it's an odd enough number, and everyone considers that difficult to work with. 37 into 100. So we want to first take 37, 137 out to start. So we have 40, and we know 37 goes into 40. I'm going to pull one out, and I'm going to break the other one up into here. So I have, right there, we have 10, 15, 20. So I'm going to take that was 20, 30, 5, 37. There, I just took 137, and I have this left, 3, and 60. So another 37. I could take a 37 out of there, so I pull that out in here. I take the 20 out, and I throw another 20 in here. I just did 10, 15, 20. That one was already there. Don't worry about it. So now we take 17 out, the other half that completes the 37, because that was 20, 30, 35, 37. I have 6 left here. That's 3 and 3. So I put the 5 there and the 1 there. So there's my answer is that I pulled out 2 37s. That's right there, 2, and a remainder of 26. That's where your remainders go. So dividing is not that difficult either. If you have a big number, for example, like 2,000, and let's divide 2,000 into 200. Oh, that's not difficult. Simple, watch this. I bring that into the next circle, and I put 2,000 in this circle here. times 5 is 1,000. 5 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 200 is 2,000. So I have 2,000. And remember, that's 2,000, 2,000, 2,000, 2,000. That's 8,000. Remember that the 8,000 circle? Now, divided by 200, we had said. 200 into 2,000. Oh, there's 200 under there. So there's 1 200, 2 200s, 3 200s, 4 200s, 5 200s, 6 200s, 7 200s, 8 200s, 9 200s, 10 200s. There are 10 200s in 2,000. Very simple. So it's according to the algorithm, which says how many 200s are there in 2,000. So as you can see, you can divide, you can multiply, you can subtract, and you can add. And this is one of the few things that can be done, because remember, this we did not call it an Aztec calendar. We called it the Nepohualtzit, the Nepohualtzit, the Tonaramat. It is a machine. It has in it the capabilities of doing several things. We used it to map out our cities. The original city of Mexico, Tenochtitlan, is divided up, and you could go to Mexico and see the streets, and you'll see, if you turn it around, you have the symbols that are here are correlated to the different peoples that lived in the different parts of town. You can see that the sun came down at a certain place at a certain time of year. You can see that the stars, the days, and the earth, and the correction, the moons, and Mars, and certain stars, all correlated within a certain period of time and certain cycles, including the sun patterns. So there is so much here, and I will be speaking more on it. This is one thing you can do. You can now use it as a calculator. Study it at home. Get the little one. All you have to do is see me, and I'll gladly give you a copy of the little calculator so you can play with your beans, put them in place, and do your math. So enjoy it, and have a good day. I want to thank you for enjoying this class, and as we go along through time, I do anticipate coming out with some more presentations on the other aspects of what you call the Aztec calendar. And as for now, you will now know that when you see this, this is called the Nepohualtzit, and enjoy your Mass with it. And tomorrow is another day, so Ometeo Walitlaneshli, and that means good day. It's been a pleasure working with you.